alkane, alkyne.
Well, why do you have two alkyne? I don't.
I don't know. It's not based on the number of hydrogens. It's based on what the bonds do.
Okay.
I don't know.
I don't know.
She threw me off.
Yeah, well, she said something over here.
We don't know what that.
I keep getting mixed up with alkene, alkyne. I know alkane. A-N-E. Yeah, I understand that one.
Look at your peak and where each stretch comes in. So where does the C triple bond?
Which one are we looking at? Alkyne?
Alkyne.
So the first one is alkane, correct?
It's
We're
alkyne.
looking at one hexine right now. So what's the first peak on that
Alkyne.
side?
Alkyne.
Alkyne. So is it called alkyne? What is it called?
CH stretch alkyne.
Okay. And then yep.
And then that
This will
little...
still be your alkane CH stretches. And this is something that's in the fingerprint region.
So we're only looking...
Remember, in the fingerprint region, we can't really say for sure what it belongs to.
So,
Because from 600 to 1400 is defined.
The first peak is alkene. Alkyne, sorry, yeah. Alkane.
And another lower frequency for alkane.
Okay. Got it.
so we don't label the fingerprint region?
No, you don't have to listen.
Yeah, so that's a good point. So the fingerprint region, we want you to understand what it represents. I mean, what is that representing? But I cannot give you a fingerprint region and expect you to be able to identify anything about it. What I'm concerned about is this right here, once we get after the fingerprint region on down, is what we're concerned with you understanding. After this, because this is a little bit low, 1500, like I said, I want you to understand it, but I would not expect you to be able to tell me anything very specific about that region. Mostly look downfield. Yes?
So for the characteristic infrared absorption frequencies, the second line of frequencies are the fingerprint, and we don't really need to worry about that right now. So
You should label them both, but I'm saying don't go into too much detail about the fingerprint.
Okay.
Right? If you can, identify every single edge. Because IR, you cannot identify every single peak. It's just like a fingerprint.
What is the little tiny?
Don't worry about it.
So just the first two.
Yeah.
So alkyne and alkane.
Back to the first one with identify those as practical frequencies. Okay, so that one, the first one, alkane.
Because it's below 3,000.
Yes.
The
So
one-
notice that these peaks are also getting bigger and they're shifting to the higher.
Okay.
So what factors answer C for us? So your bonds are getting
Strength
stronger.
of the bond of the carbon is triplet.
Can you repeat that again?
So the strength of the bond, you're going from a single, double to a triple. So all right, let's move on to number 2. 2 is fun to do, and you should be comfortable doing it because you will have questions like this on your final complication. So first thing you want to do is look at your molecules. Don't even worry about your IR structure, okay? And identify every single functional group that you have. So let's start with trans-cinnamaldehyde. What are the functional groups in there, Martha?
An aldehyde.
Trans-cinnamaldehyde. The first one?
An aldehyde. Oh.
Aldehyde. That's a benzene. Okay. So it's something that you can identify as a functional group, but it's going to be hard to identify it on your IR spectrum. Okay. So don't worry about trying to find where the aromatic is. And what else is in there?
Carbon double bond. I don't know what it's called though.
Double bond, right? So
Yeah,
alkene.
yeah.
So the functional groups in the first one are an aldehyde, an alkene, and you have the aromatic. So what's in acetophenone? Sabiha.
That is,
Is that a ketone?
yeah.
So to review, what kind of things can I have with C double bond O? Ketone, aldehyde,
Eno. Can you make?
carboxylic acid, yeah, amide. Remember that? We have an N next to a C double bond O, that's amide. If I have
You said, what she said? So you said a ketone, aldehyde, carboxyl.
and ester, good.
Have we talked about esters?
Put it down a little.
That's what an ester look like? Because we haven't talked about that. Is that correct?
Sorry?
That's what an ester looks like?
Yeah, so ester, you have to have another carbon here or something else, right? If this is an H, it would be a carboxylic acid, you have another carbon here. So benzoic acid, functional groups. They don't. Probably didn't say something. Oh my gosh. Okay. Aromatic, right? I don't even know how to do number two. Number two was a ketone. I need that. The whole thing. The whole thing. I'm not asking you to do the whole thing. I'm just asking you to do the function. We just talked about it. C double bond O, and if you have an OH here. Oh, okay, yeah. What is that? Carboxylic acid. Right? The name also has benzoic acid, alright? All carboxylic acids have the name at the end acid.
Sorry.
And so the last one, only function group in here,
So OH.
alcohol. So which one do you think will be the easiest one to do? Alcohol. Another tip for you for doing IR, two of the main peaks that jump out at you are OH and C double bond O. What's the reason for that?
Dipole.
Dipole moment, right? So C double bond O has a, it comes in around 1650 and it'll almost touch the baseline, like I mentioned. And OHs are known for being really broad. They're going to be this huge well kind of thing. You see that, and they come in after 3000. So it's in the function group region and it's well signed, right? So based on that, does this spectra here have our OH?
Yes.
Yes. So just because it has an OH, can I identify this as ketone for sure?
No.
Why not?
Because-
It would be benzoic acid.
Benzoic acid also has our OH, right? So we'll just identify OH and then we can say, okay, this could also be benzoic acid. So what would you do next to identify between these two? What's in this molecule that's not in this molecule?
Aromatic ring.
Aromatic ring, but
Double
like I
bonds.
mentioned, aromatic rings are hard to find in your ion.
Double
See double bond O, right? So you see a huge peak touching the baseline and it's even. So what do you assign this as?
Bam.
And Amber, I want to point out, it's really important to know functional groups when you're doing IR. So if you're having trouble recognizing them or remembering what they are, in your book, if you open the front cover of your organic chemistry book, there should be a list right there in the cover of what the functional group is. So that way, because when we give you this, like if I asked you on the quiz, I don't expect you to be able to tell me what an ester group is off the top of your head. We're going to give you a table, and I'm going to say, this is what an ester group is, but I expect you to understand what an ester group is. So make sure that you understand what the functional groups are, because this is going to be important in lab and in class. You're going to be expected to know it for both of those. So just make sure you're really familiar with functional groups and what they are.
So we have 3 compounds left. Which one will be the next easiest to read?
Benzoic acid.
Benzoic acid. Why?
Because
Look for an OH.
look for the other OH.
So I'm just going to scroll really fast between the 3. So you can identify which one is it.
It's
Middle
the
one.
second
The
one.
middle one, right? And that's because you have that huge broad thing above 3,000. Okay? And the reason why this is messy compared to butanol is because your aromatic
Benzoic.
hydrogens overlap. And it's just making. Which one is that? Okay. So which one is this?
Benzoic.
So
So what else do I have to make sure this one has?
Has
Right? So it's almost touching the baseline. It's at 1550-ish. Right? So we've identified identified that.
What is the first one?
So now remains two more. How would you
One,
differentiate
this
between
one.
The carbon double bond.
carbon, carbon double bond?
CO.
Anything else? Alkene and you already know where to find alkanes, right? And you know where to find alkenes. So if I scroll really fast, you have to pick between the top one and the bottom one. Which one would have the alkene peak?
Top one.
Bottom one.
Top one.
Bottom one.
Bottom.
Who was for the bottom one to be the alkene? What happened to the rest of you?
The top one.
Okay, so this is your top one, memorize it. And then this is the bottom.
I
The
said top
bottom one
one.
has the alkene, right? It has to be above 3,000, and you know it's going to be relatively short. You've seen it in the first example. And so, make sure that when you're doing this, you also identify your C double bond O, that also has it, your alkene stretches, and the other names.
So the bottom one is the
And
S.
the nominal.
Oh, that's what I thought. Is that what you asked? I'm sorry, I couldn't. I thought we was on the other one.
The bottom one is trans and
Yeah, why? Identify the piece for me.
Carbon.
Can you?
they're after 3,000.
What's that? What would you label that peak as?
CH stretch alcohol. CH stretch.
Carbon.
CH stretch alkene.
No.
Come on, look at your sheet.
It's, yeah.
Huh?
Not that one, the one with all the regions where each function group comes in. Yes. So what's above 3,000? That's in your model also.
Above 3,000 is a OH or NH or CH.
Anything else?
What I'm saying?
Right, so what do you see in your model? So you've said that this is transamaldehyde. Does your transamaldehyde have an alkene? So that is
Why?
Mm.
Why did she say that this is benzoic acid?
Because this is the OH group. Because it has a big old well.
So everyone clear? Yep. And how we assign score?
Nope. I'm going. I will. Because I. It's too much going on. Too many people talking. So I'm gonna get you inside.
Questions? If not, I'm going to move on to IR. I'm NMR.